afternoon, sir.
Good afternoon, sir. Good afternoon.
Yes, sir. Good afternoon. Madhumita,
Yes, sir.
please.
Good afternoon to one and all present here. We are now going to start this session. We heartily welcome our highly respected chief guest, Dr. Mariyappan sir, for this session. The topic of today's session is performance analysis using.
Glad to introduce our resource person of this session, Dr. P. Mariyappan sir. He has a PhD in management science as well as mathematics. He has 33 years of rich experience in teaching in the field of applied mathematics, statistics, and business administration in India and the UAE. Currently, he is working as an associate professor, area chair in supply chain management, and chair in academic tie-ups and international relations, St. Joseph Institute of Management, St. Joseph College, Trichy, India. He served as a head PG and Research Department of Mathematics, Bishop Weber College, Tiruchirappalli since 1990. In addition to that, he holds the position of International Relations Officer for a period of 2 years and held PG Department of Actuarial Science for 4 years. He worked with the Manipal Academy of Higher Education, Dubai, UAE for 3 years. Also served as a staff selection committee member in many higher educational institutions in India and abroad, and hold the position of university nominee and board of study member in many autonomous colleges, including Bharatidasan University, India. He gave his plenary lecture in many international and national conferences and symposiums. He reviews articles for many leading national and international and e-journals. Also presented more than 150 research articles in various international conferences held at France, USA, Singapore, Malaysia, Sri Lanka, Thailand, Philippines, Dubai, and Oman. He organized many international conferences and workshops in the field of applied mathematics, management, statistics, computer science, and actuarial science. He received so far 18 awards, notable ones: INSO Outstanding Researcher Award in 2022, Lifetime Achievement Award, RULA in 2019, Best Faculty Award in 2018, Dr. APJ Abdul Kalam Lifetime Achievement National Award in 2015, Best Paper Presented Award, IC Gymnatic Goa and ICAF Sri Lanka in 2015, Best Research Paper Reviewer Award in 2007. To his credit, he published so far 60 books in the area of applied mathematics, applied statistics, management, and computer science. We are very delighted to welcome you, sir, on this wonderful session of this online international faculty development program on current trends in applications of mathematics. Thank you, sir.
Thank you. Thank you very much, sir, for the introduction. Thank you very much.
Thank you, sir.
Yeah. Can I start?
Yes, sir. Please, sir.
No audio. Not able to hear, sir.
Good afternoon.
Yes, sir. Yes,
Good
sir.
afternoon, sir.
Yes, sir.
ladies and gentlemen, I will through this international FDP on current trends in applications of mathematics, hosted by School of Sciences and Humanities, Department of Mathematics, Tech. Head of Mathematics, competent coordinator of this program, learned keynote speakers, professors, research scholars, my heartfelt good. At the outset, I'd like to thank the organizer for giving me a golden opportunity to discuss the concept of data envelopment analysis with the elite audience, those who are present here. Data envelopment analysis, shortly referred as DEA. Normally, in a commerce area or a financial area, we so whenever if you want to evaluate the performance of any sort of a company, how the company is functioning or how the industry is functioning, likewise, so we need financial ratios. Usually, every year the company's balance sheet will be provided or published. Balance sheet, and we can take the data sets and we can evaluate a different sort of ratios like efficiency ratio, liquidity ratio, profitability ratio, and solvency ratio likewise. Based on this, we can come to a conclusion how the company is functioning. Okay, regarding the performance analysis of any sort of a company, whenever the balance sheet is provided, we can go through the data and we can make use of certain formulas available in the financial ratio, and we can evaluate and we can judge the ratio, how the company functions, whether it is a positive side or a negative side, or whether any kind of improvement must be made. Likewise, we can go in for analyzing it by simply looking into the budget P&L account provided by the company. Okay, so we have so many ratio analysis available in financial ratio cases, like a probability ratio attempts to measure the firm's success in generating income. These ratios reflect asset and debt management. Likewise, we have a profit margin ratio. So profit margin ratio indicates the income in dollars that the firm earns on each dollar of sales, or in terms of rupees in each rupees of sales. This ratio is calculated by dividing net income by sales. It is defined as what? Profit margin is net income by sales. Likewise, we have many ratios. Okay, ratios not only help analyze the performance of one company, but also facilitate a comparison of the performance of two or more companies within an industry or a sector. So why that we do these kind of analysis? Whenever you want to invest any money in the share market area, we would like to know how the company functions. Only we people are interested to invest money in the blue chip companies. What do you mean the blue chip companies? Companies which are excelling very well for the past 10 years likewise. So what? The risk factor is going to be reduced whenever we are going to invest in the case of blue chip companies. Okay, so we have many ratio analysis. The problem is, whenever we want to analyze any sort of company regarding the functioning capabilities, we come across so many variables. We categorize those variables into input variables as well as output variables. The number of variables of input as well as output is going to be differing according to the company concern. So we have a small, medium level companies, large level companies, and small level companies like. So according to the level of companies, we have segregated the input as well as output variables into many. But all are infinite numbers. But here the main drawback of this kind of analysis in profit ratio analysis purposes, at a time we are going to combine or consider only two ratios. Only two values to find the ratios. I said the number of variables related to the performance efficiency is going to be very high. right? Many. But what? This ratio analysis considers only 2 or 3 variables at a time to evaluate. So by considering only 2 elements evaluating a performance analysis may not give the exact level of a company. So the researchers, the applied field researchers thought of, why can't we merge all the inputs as well as all the outputs, possible cases, into a structurized model and to analyze the performance of the company. So as the outcome, we have the element called data envelopment analysis. It is once again used for measuring the performance of any set of a company. It considers the mathematical modeling approach. The mathematical modeling approach. We define here efficiency as total outcome divided by total income. The ratio of outcome versus income is going to be the overall evaluation of the performance of a particular company. Right? So this is the hurdles remover to study the performance analysis of any sort of a company. The reason is what? Currently available considers only 2 ratios or 3 ratios at a time to evaluate the measures. By considering only 2 or 3, when more than 15 or 20 variables available, is not going to give a clear picture. So we thought of going for another model called data envelopment analysis, which is otherwise called what? Performance analysis technique. Okay, DEA, data envelopment analysis. So DEA is a fractional programming methodology to measure the efficiency of multiple decision-making units, but the production process presents a structure of multiple inputs and outputs. Here, for discussion purpose, we consider only production process, but what can be applied for any or the whole companies to study the performance analysis. Here, I have to stress on DMU, right? Decision-making units. This tool can be utilized to study at a time only one set of an industries. Say, for example, I can consider only IT industries, different IT industries, different educational university or colleges, right? Likewise, different companies available in the production centers, different companies available in the publication sectors. Likewise, we can move on. So the cross study is not possible. That is the only disadvantage here. Which means that I cannot study IT industry versus education industry, IT industry versus a manufacturing industry, IT industry versus the different universities likewise. Because this DEA is totally based on the input as well as output variables available in the respective companies. When you move out the different sort of companies, the input as well as output variable may differ. So this model can be implemented only well within the industry. So IT sector, only IT sector. Manufacturing industry, only manufacturing industry. Colleges, only colleges. Universities, only universities likewise. So the father of this particular DEA is nothing but mathematician, a great mathematician, statistician Farrell, 1957. The pivotal work measuring the efficiency of decision-making units by Charles Cooper Rhodes in 1978 applies linear programming to estimate an empirical production technology frontier for the first time. So Farrell being the initiator and followed by Charles Cooper Rhodes in the year 1978. It's a non-parametric method in operations research and economics for the estimation of production frontiers. Because initially, these models were utilized only to study the production efficiency, the constant production, but can be applied for anything and everything. It is used to empirically measure productive efficiency of DMUs. Non-parametric approaches have the benefit of not assuming a particular functional form or shape for the frontier. However, they do not provide a general relationship relating the output and the input. We know basically the production process as what? As inputs, process, outputs. Whatever be the case, we require the basic as inputs. All the inputs are requisited or enter into the processing area and converted as a products, and it is called as an output. So this is the normal structure for any sort of a production process. So here, decision-making units. DMUs can be visualized as manufacturing units. Departments are the very big institutions like universities, schools, bank branches, hospitals, power plants, police stations, tax agencies, IT industries, cement industries, oil industries, likewise. DA can be fruitfully applied to measure the execution of the efficiency of all these kinds of DMUs. So fundamental concepts of efficiency of evaluation. The efficiency evaluation is nothing but the efficient transformation of the different types of inputs into different types of outputs. Mathematically speaking, it is equivalent to the ratio efficiency equal to total output divided by total input. This is a ratio we are going to make use of. So here we consider many output variables as well as input variables available in the organization. So here this diagram communicates that what? To the various industries available, we can imply DA across industries, and we can make the study regarding how the companies are moving, how the companies are growing, or what is the status of the particular company. So we can use for education sector, manufacturing, fast food, BFSI, healthcare, FMCG, retail chain, and malls, and others like. So it can be employed for any sort of an organization. So prior knowledge requisited or needed. The DA modeling requires the concept of mathematical modeling related to the fractional programming and linear programming structures discussed in operations research. So why we call the fractional programming approach here? The formula, right? The evaluation or the efficiency here is summarized as what? Total outcome by total input. Okay, so that's why it is called as a fractional model, right? A fractional. In any modeling, the structure contains the following elements: the objective function, conditions, and the non-negative restrictions likewise. So this is the basic linear programming structure. We have objective, we have a set of conditions, and we have a non-negative restrictions. Normally in industry, we'd like to maximize all the cash inflows and want to minimize all the cash outflows. That is a basic concept. That is, maximize the revenue, maximize the profit, minimize the cost, minimize the time, likewise. And here, suppose we visualize of a maximization model, C may be the profit per unit of the different structures. They're all the BIs referred as the resources. So the available resources should be utilized either partially or fully. If it is requested, we can go in for purchasing some more things. So it is what? Less than, equal to, and greater than. B1, B2, BM. M different resources, N different products. This is structure of linear programming. This model can be created what? To maximize the profit or to maximize the revenue or to minimize the cost, to minimize the time, to minimize the wastage likewise. So these kind of LPPs can be resolved using many methodologies. But in the persons who are already teaching operations research or already those who have done operations research as a paper in any of the undergraduate or postgraduate areas, you know very well, we have a manual process of solving linear programming or any method available in operations research. But in the real-time cases, it is impossible to resolve. Products going to be very high. Usually, a nominal case maybe 25 to 100 variables can be considered at a time. So manual evaluation is not that easy to. We can do the conversion part, but manual evaluation is not that easy to. So we require a package is already available, Lindo, Lingo, the recent case of Torah, likewise. Even we can use the Excel sheet to resolve the linear programming or any OR models. So here, for resolving, we make use of already the software available for DEA, or we can make use of Torah package to resolve the particular model. So before getting to the actual DEA, I want to explain through a simple application to hospitals how a mathematical model can be implemented here. Just to go through the problem, it can take 2 to 3 minutes time to read the model. Just read it, I'll explain. Just read the problem. So one of time I can brief the model here. A hospital is available. A hospital would like to go in for recruiting nurses for their day-to-day utilization purposes. We know very well hospital may have inpatient as well as outpatients. Okay, the authorities splitted entire day into 8 shifts. Shift 1 started at midnight 12, and one shift is considered to be 3 hours. So 24 by 3, we have 8 shifts. Shifting time is given here, 12 to 3, then 3 to 6, 9 to 6, and so on. Then again night, 9 to 12. And the numbers here provided, these numbers are what? In shift 1, the hospital needs a minimum 30 number of nurses. In shift 2, 20. Shift 3, 40. Likewise, shift 8, it is 40. So these are the number of nurses required to run the shifts. Otherwise, a nurse would work for 6 hours at a stretch. Which means that a nurse entering into 12 midnight can leave only by 6 o'clock. Nurse entered by 3 o'clock in the morning can leave only by 9 o'clock, likewise. So after going through this model, you have to answer the following questions. Whether the objective is going to be maximizing or minimizing a situation, number of variables needed, number of conditions requisited, and what is the non-recruiting nurses. It is obvious when you're going for recruiting of nurses, the company should pay the salary towards the end. The company should pay a salary towards the end of every month, which means that this model involving cash outlay, the cash is going out. So any company or any hospital is very much interested to minimize the total number of nurses required for the entire process. Okay, so here the objective is going to be, this is the question to be raised and answered. I've already stated. And the number of nurses required is to be evaluated, or the number of nurses required should be minimized overall, because the cash is going out, right? It is not the cash inflow, it is cash outflow. So to be minimized. A number of variables required is what? 8, because the company is going to recruit personnel for every shift. So shift 1, shift 2, likewise shift 8. Every shift the company is what? Recruiting. And for every shift we have a condition, the number of nurses required. So we require here 8 variables and 8 conditions. So here let us consider XJ stand for the number of nurses recruited in the jth shift, where XJ should be positive and integer, because XJ refers what? Number of personnel. XJ cannot be a fraction. So for every shift we have minimum number of nurses to be operated. So we have 8 conditions and 8 variables. And the objective is what? Minimizing the total number of nurses to be recruited. So I'm going to tabulate all the information. Okay, here it is tabulated. This indicates X1 number, let X1, X2, X3, etc., X8 be the number of nurses to be recruited in different shifts. So X1 nurses are coming in and they are leaving only at the end of the second shift. X2 nurses are coming in, second shift, they are leaving in the third shift. Likewise, X3 leaving here, X4 entering, leaving here. Likewise, X8 entering here and leaving in the shift 1. So these are the numbers needed for every shift. So we want to write down the objective function for this particular model. I said the total number of nurses to be minimized. The total number of nurses to be minimized. So I'm going for X1 number, X2 number, etc., X8 number. So adding everything, we have X1 plus X2, etc., plus X8 being the total number of nurses to be appointed or to be recruited. This total value must be minimized. In operating research throughout the globe, the name of the objective function is normally referred as the letter Z. So here Z equals to X1 plus X2, etc., up to X8 be minimized. So the objective function is going to be minimize Z equals to X1 plus X2, etc., up to X8. Okay. Now let us move on to the constraints. Let us first consider the second one is also here in shift 2. X numbers recruited in shift 2 is also available. So number of nurses available here is what? X1 plus X2. So this X1 plus X2 number must be minimum 20. To represent this in the mathematics, greater than or equal to 20. Means what? Minimum 20, maximum it can be anything. So X1 plus X2 greater than or equal to 20. Here in the third case, X2 people entered in shift 2 will be available and X3 people entered here available. So total is what? X2 plus X3. This X2 plus X3 should be always more than 40. So that is a structural model. So this is the mathematical structure of this case. Minimize that is equal to so much. That is X1 plus X2 extra up to X8, subject to all these 8 conditions, where all the variables are positive. Variables should be always positive. Okay, so manually it is impossible for us to solve this. It will take time, lot of time. So we are going to make use of a package. As the Lindo, the total number of outputs and inputs must be in a reasonable level. Don't worry about these kind of notations. Formulation of a mathematical structure of additive type I stands for input and J stands for which variable is it. First output, first input, second input, third input likewise. So I1, I2, I3, etc. IL, right? So I'm considering L number of input variables and N number of outputs, O refers output. Okay, O1, O2, O3, etc. up to OK. And for every input and every output, we want to give the weightages. That is called UI. UI, that is UJ, refers the weight for the input variable, and VK stands for the output variable.
98652.
Okay. DA for higher education institution. So here I'm going to study about DA, the performance analysis of the higher education institution. Okay. What I mean actually inputs as well as outputs with respect to the education institution. Consider inputs as what? A number of professors available, number of students available, infrastructure facility, etc. are considered as inputs. What is the output? Passing percentage, minimum number of campus placements, etc. That is the output. Okay, for clarification is explained here through an example. What I mean input and what I mean output. So this form is what? A total input, okay, virtual input, or total output divided by the total input. Okay, summation. And we define the efficiency. Efficiency always lies in the interval 0,1. When it moves on towards 1, we call highly efficient. If it is moved towards 0, it is going to be less efficiency. The DMU, which has the maximum efficiency, is usually considered as a reference DMU, okay, or as a best one. So efficient level is what always lies between 0 to 1. So here what? I'm going to consider n number of companies for the study. Small m refers what? Which DMU I'm considering. So mth DMU, nothing but what? M is 1 to n. Then efficiency of this mth DMU is what? Referred as E suffix m. So OKM is the output variable. Then IJM being the input variable. UJM being the weight assigned to the input DMU. VKM weight assigned to the output. Okay, the notations, don't worry about the notations. This is a corresponding model for compare. Maximize E suffix m equals to total output divided by the total input. Because the efficiency is maximum 1, I have here the ratio. The ratio should be minimum 0, maximum 1, given as a condition. So this is the model created for the mth company. So maximize E suffix m, maximizing efficiency of the mth company is nothing but total output divided by the total input. This is the efficiency ratio. This efficiency ratio should be well within 1 for all the previous cases. So this is what? It lies between 0 to 1. The current DA is about a fractional model, which is too complex to resolve. So the same can be converted into an equivalent linear model using a simple normalizing procedure. Means what? Fractional model is not that easy to resolve, so we convert it into a linear model by using a normalization process. So I'll explain the same thing through an example, which will be very easily can be considered or taken into. Just consider a rough data set. Go through. I have 5 industries. There is 5 institutes, education institutes. We call A, B, C, D, and E. 5 different educational institutions. For the study, right, I'm considering few inputs, only one output, number of students passed, and 2 inputs. Because with the first model introduced, I'm considering what? Only very few output as well as input variables. So output 1 is what? Student number of students passed, out. Number of students admitted, input. Number of faculty recruited, being an input. So students admitted 4,434, faculty is 344, and what? Number of students passed is what? 1163. Likewise, second institute 1439, 5662, etc. Please go through the data sets. Please go through the data sets, right? In order to convert this into mathematical model and to simplify the model, I am going to consider in an easier way this O1, output 1, referring as variable x1. Here, this is input 1, referred as x2, this as x3. We can consider the efficiency ratio as what? Total input divided by total output, right? That is what? Efficiency is what? Total output divided by the total input. So here, output is going to be 1163 times x1. This is a weight. 1163 times x1. In inputs, we have 2. So we have to add 4434 x2 plus 344 x3. So the efficiency of the first institute A is nothing but E suffix A is nothing but 1163 x1 divided by 434 x2 plus 344 x3. Similarly, we can go in for institute B, C, D, and E, the ratios. It's very simple. 1439 x1 divided by 5662 x2 plus 513 x3. Then 533 x1 divided by 7200 x2 plus 720 x3, and so on. So we'll find the initial. This is using what the actual suffixes I'm reducing here. Instead of V1A, I'm going to take as a x1, and this as x2, this as x3 for easy application remembrance. So E suffix A is what? Total output divided by total input. EB, total output divided by total input. Likewise, for all the other, we can go in for evaluating. So this is the ratios, this is the efficiency ratio, or this is the performance ratio of all the 5 institutions. This is the total output divided by total input of A. This for B, this for C, this for D, and this for E. Okay? We know very well all this efficiency is maximum 1. So while considering or while studying the cases, we have to construct for each one as a 5 different problems. In the first case, I can go in for maximizing E suffix A with respect to all these elements. Maximizing EB, second case, EB with respect to all the cases. Likewise, EE with all the cases. So the model can be here. The first one for A, maximizing E suffix A equals to 1163x1 divided by 4434x2 plus 344x3 subject to 1163x1 divided by 4434x2 plus 344x3, which is less than 1. Likewise, second one less than 1, third one less than 1, fourth one less than 1, and the fifth one is less than 1. This is a model. So this is the model for one institution. And replacing A by B, we have maximizing this value, maximizing the second value, subject to all this. Third one, maximizing this third value, divided by all this. Then fourth one, maximizing this function, subject to all these functions. Then fifth one, this one versus all the one. Okay, I'm considering only the maximum is 1. So that's why I have what? Less than or equal to 1 here. So as such, this model looks like a fractional programming. Here, both the objective and the constraints are in the form of a fractionals. So this model is referred as a fractional programming problem in mathematics. In what? In operations research. I want to convert this model into a linear model, into a linear programming model. I can give you 2 to 3 minutes time. I can give you 2 to 3 minutes time how we can convert this into a linear model. I want to convert this fractional model into a linear model. So for example, in the objective function, I should not have fractional values. Likewise, in the constraints, I should not have fractional values. I said in the theory part, we are going for using a normalization procedure. Right? Normalization procedure. How I can convert this as a, how I can remove the fractional values here? Just think about it. Take 1 or 2 minutes time. It is very easy. That is, I can consider or I can take 4434x2 plus 344x3 as 1. Put as a condition. This condition is included in the constraint area, right? If you take this value as 1, this becomes what? 1163x1 divided by 1, nothing but 1163x1. Additionally, what? I have to have a conditions. 4434x2 plus 344x3, which is 1, as a condition must be included here. Regarding these cases, just you can cross multiply and you can take everything to the left. This is 1163x1 less than or equal to cross multiply 4434x2 plus 344x3. Take all to the left hand side. Because what? Fraction will be removed. Likewise here, cross multiply and take everything left. Then last one, cross multiply and take everything left. So this is the corresponding conversional case here. See, this value, this is taken as what? 1. So maximize E sub x a is 1163 x1 subject to all the conditions. Subject to all the conditions. Okay, so this is very simple. So denominator I'm taking as a 1. So this becomes what? A normal function. The fractional form is gone. Okay. And cross multiplying and taking everything left, all the constraints becomes what? The normal conditions. So now what? Fraction is removed. The fraction part is removed based on the assumption the denominator is 1. Now this is what? Usual LPP. This is for the company A or for the institute A. Similarly, I can go in for the second college. Maximize E suffix B equals what? 1439x1. Subject to 566x2 plus 513x3 equals to 1 and all the conditions. That is for B. For the institute E, maximize E suffix E 1419x1 subject to 5464x2 plus 456x3 equals to 1 and all these conditions once again. So I have right now 5 different problems for 5 different institutions. These models can be solved by using any set of packages, either Lindo or Lingo or Tora or MS Excel, whatnot. We can resolve. Here I'm using Tora to resolve, Tora package to resolve. The object is what? Efficiency here is what? 0.544. Efficiency what? Approximately 0.55. Or the efficiency rate is 55%, which is not closer to 1, which means that institute A is not functioning in an efficient way. And these are all the value for the coefficients. X1 0.000468, X2 0, X3 is what? 0.002970. Best value. Okay. So optimum value for the company or for the institute A is 0.5442483, approximately 0.55, which means that the company, the institute A, is working with the efficiency rate of 58%. So what's the conclusion here? This should be put into various evaluation, should identify where actually they are lagging, and they should move on to what? Achieving the level 1. That's the meaning. Like this, we have to compute for the remaining 4 institutes, and by considering all the 5 values, we have to judge which one is efficient, which institute is efficient. And this is a basic example how you can convert into a DEA model. We want to study the efficiency of 5 different institutes. The data is provided for 1 output and 2 inputs for all the 5 institutes. We constructed 5 different DEA models. One is to the 5 different institutes. And we convert that fraction model into a linear model and used to resolve using linear programming techniques, other packages, Lindo, Lingo, as well as Tora, etc., etc. And this is the final value. This communicates the efficiency value for the institute A is 0.544, which is not up to the mark. So this institute A is not doing well. Likewise, we have to compute the remaining 4, and we have to compare among the 5 which one is having the highest efficiency. So the study concludes if the efficiency rate is 1, considered to be the highly efficient. Okay. So this is the analysis utilized to study the maximum efficiency or to analyze which industry is functioning properly. A similar such study is designed or analyzed to know the efficiency of a qualified or quality of living condition among the Asian countries using the which of the Asian countries qualified to live, or which of the Asian countries have a quality of living conditions likewise. So for this study, researcher considered what? 15 Asian countries, collected the secondary data for the years 13-18 through the website numbo.com. And findings: India, Indonesia, Japan, Singapore, and UAE are doing extremely very well. The remaining countries are not up to the mark, which means these are the 5 countries having a quality living index. So we have 48 countries, out of which the researchers opted only 15 countries. And all the 15 countries data is gathered and the study is made. So these are all the inputs and output variables opted from 2013 to 18. Every year we have to compute cost of living index, local purchasing power, groceries, pollution, then quality of life index, and safety index. The website is provided to collect the data. And this is the data set for the first year, 2013. We considered 2 outputs and 4 inputs. So 2 outputs referred as O1, O2. 4 inputs referred as I1, I2, etc. up to I4. And these are all the elements here for all the countries' data. So we can have the output variable as well as input variables as what? X1 and X2 referring outputs. So this O1 is referred by X1, O2 referred by X3, X2, and this is by X3, this is by X4, this is by X5, and this is by X6. So I can write a problem for any company. For example, efficiency to China is 31.5 X1 plus 73.13 X2 divided by 60.72 X3 plus 37.27 X4 plus 66.43 X5 plus 89.35 X6. For India, 73.7 X1 plus 27.88 X2 divided by 30.24 X3 plus 61.92 X4 plus 32.51 X5 plus 77.48 X6. Right? Here the problem considered for India. So for India, this is a column, this is a row considered. This is the X1 plus this is the X2 divided by this is the X3 plus this is the X4 plus this is the X5 plus this is the X6. So we have here. maximize ease affects India, the problem, the model for India. And on all the 15 countries, ratio less than 1. Okay, as usual, I can convert this as non-fraction by considering this denominator as 1. This becomes max India is what? 73.7 x1 plus 47.82 x2 subject to this entire denominator 30.24 x3 plus 61.92 x4 plus 32.51 x5 plus 77.48 x6 equals to 1. And cross multiply and take everything to the left. And this is the equivalent LPP. This is the equivalent LPP. Already 15 conditions. This one more is added. We have a 16 conditions. So a 6-variable model with 15 constraints cannot be solved manually that easy. So we go in for packages. So here we have two different models. One is a constant return. Other one is a variable return. So on the whole, for each year, 15 fraction models to be constructed and then transformed into linear programming problems. The same to be solved by using packages. The data is collected for 6 years. That the total number of problems constructed and solved is 90. And this communicates the efficiency for the year 2013. 14, 15, 16, 17, 18, and the average is taken for all the years. So consider this, go to this column. For India is 1, Indonesia is 1, Japan is 1, and Singapore is 1, and UAE is also 1. And UAE is also 1 here. Okay, this is the mean value for constant return to scale, and this is the mean value for the variable return to scale. Okay, and I want to have an overall mean for these two. Find the average. So China is 0.9, India is 1, Indonesia is 1, Japan is 1, and Singapore is 1, and UAE is 1. So in this column, look for efficiency 1. The corresponding elements are doing extremely very well. So as per the better living conditions, we have India is good, Indonesia is good, Japan is good, and Singapore is good, as well as the UAE is good. Next, Turkey is 0.99, is somewhat almost 1. And Thailand is 0.97, and South Korea is 0.95, likewise. So the base is what? The 5 countries: India, Indonesia, Singapore, UAE, and Japan are the best countries to live according to the data sets provided. Okay, comparing both analysis, one can conclude that India, Indonesia, Japan, Singapore, and UAE is doing well. And regarding this particular applications, I've gone through these kind of a model as a research articles during my presence over Dubai during 2005. Then from the day onwards, I started collecting the data, the papers related to these particular areas. I came down to India in the year 2007, and I started working on this from the year 2012 onwards. Based on this data analysis, 3 of my candidates already got their PhDs. And when I started in the year 2012, we had only the normal applications. Now it is move on to a different structure, right? 1 stage, 2 stage, as well as a 3 stage models. Myself started in the year 2012 in India. Currently, many people are doing in this application. So here, this data analysis considers many variable at a time. Many variable at a time. Many variable at a time. So that is the most promising case of this particular model.
Of this approach,
No
Error.
limitations.
there is no error, sir.
No error. No error.
Okay, thank you, sir.
No error. Gives you the exact solution.
Okay, sir.
It gives you
Thank you, sir.
the exact solution. So whenever the company, the hospital needs exactly 150 nurses to run the show effectively. It is the best solution and unique solution.
So the nurses allocation to patients ratio, nurses to patients, that ratio,
Yeah.
does it matter, sir?
So here, my main aim is nurses should be employed in every shift. The two, second condition, in every shift we require a minimum number of nurses. Okay, for which only I'll consider a model. And further, if you want to classify the number of ratio of patients and outpatients, can be included and can be incorporated as, and we have some more conditions will be added.
Okay, sir. Okay.
Okay,
sir.
that is
Thank
additional
you.
case,
Okay,
additional
sir.
one.
Okay, sir. Thank you, sir.
Okay, most welcome. Thank you very much for your patience listening. Any more questions?
Wonderful, doctor. As usual, fantabulous presentation with all the workings of the models. We learned something about the, especially out of the financial sector also. Thank you, doctor.
Audience, any other questions, participants?
Any questions, sir?
I think no questions, sir. Can we conclude, sir?
Yeah. So Dr. Prabhakaran is going to ask a question, I think. Yes, Prabhakaran.
Sir, DEA
Are not asking questions, sir. They are saying about feedback.
Okay, just okay.
Excuse me.
financial sector in with reference to insurance is very useful, especially in the Torah field. Thank you, doctor. Thank you very much.
Madam, please. Madam, please.
Sir, for DEA, we can do the software with the DEAP. That also we can use, sir.
Sure. That's what I'm saying. We have a specific cases. DAP can be used.
Is there any software other than DEAP, sir, for DEA solving?
That's what I told you. That's why I given Torah, Lingo, conversion of an LPP.
Sir, excuse me, sir. I want this PPT for my reference, sir.
No problem. I'll send it. I'll send it across. Don't worry.
Okay, sir. Thank you, sir.
Welcome.
Is there any others? Yes, I think no doubt, sir. Sir, can we conclude the session, sir?
Yes, sir. Yes, sir.
Madhumita?
Yeah,
Sir.
proceed.
Now, I conclude this session with a vote of thanks. Thank you, sir. Thank you so much for your informative presentation. You have explained us with much patience and with much clearance. Once again, thank you, sir. I also extend my thanks to all the participants. Now, this session is over and the next session will start at 10:45 a.m. tomorrow. Thank you.
Sir, tomorrow 4 o'clock you will join, sir. Mariappan, sir.
Okay. Tomorrow 4. Okay.
4 o'clock, sir. 4 o'clock.
Okay.
Yes, sir. Thank you, sir.
Okay. Welcome.
Yes, sir. Shall we wind up, sir?
Okay, sir. Okay.
Yes, sir. Thank you. Thank you so much, sir.
Okay.